So let's start. Welcome everyone. As you can see, I'm not Professor De Russis. I hope that the majority of you already see me during the last laboratory. My name is Luca Mannella. I am your teaching assistant for this course. And it could happen, like today, that when Professor De Russis is not able to come, I would replace him for the lectures. I'm a PhD student of the SQLite research group, which is the same group of Professor De Russis. And obviously, I'm a researcher here in Politecnico di Torino. Our research group works on intelligent and interactive system, and while Professor De Russis is more focused on web stuff, human-computer interaction, I'm more focused on cybersecurity of IoT and smart home systems. So if any one of you is in cybersecurity path, maybe next year could be interesting in contacting me to having a master thesis. So I just promote myself. But that's it from my side. Let's start talking about JavaScript, which is the reason why we are here. Last day, in the last lecture, sometimes I will check the registration just to be sure that everything is working. Last time you should start asynchronous programming. You should see a bit with the professor. Today we will go on this topic. We will discuss a bit about this kind of stuff that it will be very useful also to interact with databases, which is the main goal of the laboratory that we will have the day after tomorrow. So probably the professor already told you that JavaScript is single thread by default. So JavaScript starts in a very strange way, and then it was continuously improved. So then they tried to make JavaScript asynchronous, even if it is not by default, through some how can I say, some tricks, like taking advantage of what we have, the execution environment. So like using the browser, using Node.js, we try to create asynchronicity. Obviously, we need asynchronicity because it is, let's try to imagine to have a web application that in the moment in which you are typing something in a form, you are stuck there until you press enter, or try to imagine an application that is completely frozen in the moment when it is collecting some information from the back end. Obviously, it's something that it is frustrating when you are using a web app and it is not answering to your commands. You immediately think that the app is broken. You try sometimes to refresh the page. So we need some mechanisms to improve the user experience and to let the user to understand that the application is still working. Okay, JavaScript are event-driven. And yeah, that's another important point, that JavaScript typically is event-driven. So we experience the fact that we are doing something and an event is triggered, and so the application starts managing something else. So this is something that I hope that you are used to. Okay, I don't like the wall of text slides, so sorry, I will be lose a bit sometimes. Okay, so we have this construct which is called asynchronous callback, which is basically I hope that you already know what is a callback. Is basically a function that calls another function. If you look at this slide, you will see something that we did not at the moment in the laboratory. So we used console.log to print something on the console, but right now we never asked to the user to insert something in the console. This was deliberate because I don't know if you remember about your first laboratories of computer science, like C programming or Python programming. One of the most common application is, ask to the user to insert a number and then multiply the number or stuff like that. We decide to do not do that because JavaScript was not designed to be this kind of interaction. So to ask the user, please enter a number, you need a synchronous callback, which is something that we did not teach you until now, that are in the third week of the course, if I correctly remember. So, for instance, here you can see a piece of code that is able to ask the user, how old are you? And the user, through a callback function, is able to reply. So, in this way, we are handling an input-output operation, but in the meanwhile, the program is not stuck, so the user can still move around the page and stuff like that. And as I already spoiled you, using asynchronous callback, it's very useful to interface with a database. Just to be 100% sure, everyone knows what is a database, right? Okay, is there anyone that never used a database? Okay, is there anyone that doesn't know what is a database management system, DBMS? No, no shying, raise your hand. Not a big deal. Okay, just to be 100% sure. Awesome. Okay, so basically, without this kind of construct, your user will be blocked until the user press enter. For instance, if you set a timeout, I don't remember, do you already see the set timeout callback? Does the professor already show you the set timeout callback? Never? Okay. So it is in the next slide, but just to be sure. For instance, with the set timeout callback, which is this one, you can delay the execution of a function after a certain amount of time. For instance, here you are creating this callback with a simple console.log, but obviously you can put whatever you want here. And this callback is executed after 1 second, because this value is in milliseconds. So you create this function, and when the time is elapsed, the console.log is triggered. And obviously, without an asynchronous callback like this, considering the fact that JavaScript is single thread, single process by default, you will be, let's suppose that you are instantiating this kind of callback, and then you would like that the user reply to this question. If the user does not enter any input, after the elapsed time, the callback is not executed because everything is single thread. Thanks to this kind of callback, you will be able to manage many operations, like you have many threads, even if theoretically you don't have it. Okay, and another useful callback to asynchronous callback to delay with time is also the set interval, which is basically the same callback as set timeout, but it is repeated many times. So here you have basically the same callback here, set timeout, call my function after 2 seconds with these parameters, and then my function is repeatedly called every 2 seconds. To stop this behavior, you have another function which is clear interval. You have to give when you use the set interval, you retrieve the ID that identify. Okay, do you have another question? Okay. When I do the set timeout while passing the parameters to the function, this one on the right, okay?
Does it pass the original value of first param and second param, or like if I modify them in the 2 seconds, does it get the new value?
Okay. I repeat also for the video recording just to be sure. Are you asking, when I call this function, and here I have these 2 parameters, then 2 seconds elapsed, and what happened if I modify these parameters in the 2 seconds, right? This is the question? Okay. We should test later to be 100% sure, but theoretically, in the moment in which you are giving the parameters to the function, I think that the function have the value of these parameters and use the parameters that you give in the moment in which you allocate the function. But probably it's better to have a test, because you will see we are explaining you this function because are very simple callbacks, asynchronous callbacks, but it is quite rare that consider that the focus of this course is developing a React application basically. It's very rare that you set a timeout. So I never tried what you asked, so it is better to try to do that. But I hope that I answered to your question. Remember me if I forget later, because you know that I have a short memory. And then with a clear interval, as I was saying, you stop this mechanism. So in the moment in which you have allocated a set interval, you can clear this kind of behavior using clear interval. Okay, obviously, some of you could ask, how can I handle an error in callback? Because it could happen that a callback fails. There is no official way to deal with it. There are best practices. We will see a couple of them in the, for instance, we will use an SQL library later on. Again, I hope everybody of you knows SQL language, right? Is there anyone that never wrote a SQL query? Okay, very good classroom today, okay? I'm happy about that. Okay, so as I was saying, there are no official ways, only best practices. Typically, in this kind of function, you see that you have two parameters. The first one is used to manage an error, if an error occurs, while the other one is used to manage the data. So for instance, as it was written here, this is a strategy adopted by Node.js, for instance. Okay, so let's start talking about database access with SQLite. Okay, basically, if you know what is database, it's something that you need to have server-side persistence. Think about the particular kind of behavior in which we are working on. We have a web application, and obviously the web application many times manage a whole amount of data. Right now we are 100% used to web app or mobile app, so you know how they works. You know that they can manage very huge amount of data, and it's not thinkable to have the front end to manage this huge amount of data. So usually in the back end, you create a database. The database is charged to manage the data of all your users, and then the data are moved to the front end when they are needed. And there are many DBMS. That's the reason why I asked you before if you know what is DBMS. And specifically in this course, we will use SQLite. That if you are if you know a bit about DBMS, is basically one of the worst DBMS from many point of view, because it's not particularly powerful in managing heavy query or stuff like that, but is on the other side is extremely simple. It's basically just a very big file with something on top, and it's perfect for this course because we are not focusing on DBMS. It's just a tool that you use to create your web app. And considering the fact that it's extremely light, is something that is very used also in real-world application, especially in the mobile field, where you have to install sometimes a DBMS on your mobile phone. And that's it. So we will see a bit later when we program a bit, but we have this module which is called SQLite 3. So you have just to type npm install SQLite 3, because starting, for instance, the lab of Thursday, you will have the library at your disposal, and then you have to instantiate the database. Remember to close the database in the end of the application, and we will see the function, the methods that allow you to interact with the database. Okay, so I don't want to spoil your time in discussing SQL query, especially if you know them, but just a couple of words on the methods that the module gives to you. We have, for instance, this, remember, DB is the name that we give to the instance of the SQLite database. With, for instance, here you have a database which is called exams.SQLite, and as you can imagine, it's a database that manages exams. So here we have the instance using the method all. This method executes an SQL query that you give as parameter, and then you will obtain error in case there is something wrong, or all the rows in case everything is okay. You have also the method get that get only first row of the results. So for instance, you can use this method if you are 100% sure that you will have only one row. I don't know, select something where from table X where ID is equal to something, you will have one row. And you have also this db.each that execute a callback once for each result row. So it could be used to manipulate the rows that you obtain one by one. You should know, I forgot something. Okay, here you have just a quick example. For instance, you have rows for each row, and you can print the row one by one, or if you want to have a similar behavior, you can use the db.each method instead of getting all the rows and calling another method. Obviously, you should know that the SQL is not only query, but allow you also to create table, insert data, update data, and stuff like that. So you have a method to do so. And you see that in the callback function, you can use some extra parameter like last ID that give you the last ID inserted in the database, or this value that inform you about how many rows your statement has changed. As probably you notice if you are wake up and it's not obvious at that time, in the previous instruction we used arrow function, while in this one we put a traditional function. From your point of view, is there a reason why we write the statement in this way? Just to see if you are not sleeping. I didn't hear you, sorry. Yeah, that's basically the point. Because we would like to access these values, but when you use an arrow, we will see that later on in the course, so basically it's a minor spoiler, but when you use an arrow function, the arrow function has its own this. So if here I write an arrow function, I do not have this value, or in JavaScript you can do whatever you want. So basically I have these values, but they are undefined or null or stuff like that. Because the this that we are referring here is the instance of the database. And we need to have this kind of function to access that kind of this and not the this of the arrow function. Is it clear? I know it's a bit strange for the moment maybe, but I hope that it will be clear in the next lectures. Okay, obviously you have the possibility to use parametric queries, like, basically every other programming language. Okay, to write your parametric query, you have to replace the question mark. You have to replace the value with a question mark, and then you have this array of values which are filled with the parameters that you want to use. Again, do you know why is it important to use query parameters instead of hard coding the parameters? Okay, you took one point, the SQL injection. So for security reason, with query parameters, it's a little bit difficult to execute SQL injection. That's right. And there are two other minor reasons, but that's the most important, by the way. Okay, one is performance, because in some DBMS, try to pre-compute the queries. So when you have query parameters, the DBMS is able to pre-compute the query and optimize the performance. And the third one, which is the simplest one, is maintainability, because it's much more easy to maintain a query written in this way. You are able to change the parameter without having too many issue in checking, okay, I'm writing the string in the right way or not, is this the right value or stuff like that. Okay, this is a very simple example that we will use in the next slides. So here we have a database, but maybe I can show you directly the real database, I would say. So for instance, if I take this exams.SQLite, okay, it would be a little bit difficult considering that I do not mirror my screen, but basically, I don't know if you ever seen this program. This is basically a database browser for SQLite database. If I correctly remember, I also wrote the link about this program in the next laboratory text, so you can download it. But it's a very simple tool that allows you to navigate inside the database. And as you can see here, we have this database with a list of exams. And it's nothing surprising that you have the course code, the name of the exam, and the number of credits. And then there is another table, which is the score table, in which you have associate a certain user in a certain date, which kind of score achieved in that course. So very simple database. I hope that no one of you is surprised of it. Too many. Okay, so that's the database. And we have this very simple query in which you see we are importing the SQLite tree. This is the same import approach that we use for the JS. The database is called in this way. And here we have a simple query in which we say, okay, give me all the exams, all the courses that have basically a score. You execute the query. If there is an error, you throw the error. Otherwise, you are printing. Okay, and you have something like this on screen. Okay, you will see this kind of stuff. Again, this is something that if you want, we can see. Just to be a bit more interactive. So it should be not this one. Transcript. Okay. It will be difficult. Let's try. I think that anyone is able to see the screen, right? Can you read what is on the screen now? Okay. So here is the same stuff that we have on the slide. We have the query, select, from, course, and stuff like that. So we are in database folder. And this is transcript. Okay, so if I did node transcript, no surprise, here we have the list of exam, okay? So if, for instance, decide to do, okay, instead of printing the row here, let's put the result, the rows in this array, and then print the array here. What do you expect to see? Any one of you expect a different behavior? You can also say no, it's the same. Okay. A little bit more, sorry, okay. Is better. Can you read now? Okay. my mouse, okay. Okay, I would like to show you something that apparently does not work. I don't know why. Okay. Let's stick to this slide, basically. But, okay, what you should experience, I don't know why the example is working perfectly, but what you should experience is that you have this kind of query, db.all, that, as I told you before, is an asynchronous callback. Okay, so you don't know exactly when the query is executed. And then you are trying to print the result of this callback. So probably my PC is perfectly unable to manage multiprocessor, multi-threading, I don't know. Because the point that I would like to stress you and to show you is that you have this kind of instruction that are written sequentially. Okay, so you have this array, you have this query. You are asking to the database to give you this data, and then you are trying to print this data. Okay, but considering the fact that this callback is executed asynchronously, this is not executed, this is not strictly executed in the moment in which you are calling it. So it could happen that in the moment in which you are trying to print something on screen, you did not have yet the results. And so you could experience that you just see this console.log line and you do not see the results because they are not yet computed. So I don't know, maybe considering the fact that I tried this example last night, maybe I have something in cache or I don't know, but this is the kind of behavior that you could experience. And this could create several issues. I would also like to show you another example, hoping that this time everything works as expected, which is this queries. I lose my mouse again, okay. Okay, again, here we have this kind of, maybe if I move here, it's better to read, okay. We have this kind of query, okay, in which you are trying to execute one query, which is db.run, in which you are inserting into, this is obviously another database, this is just another database with a table which is called numbers, and then inside the numbers you have a list of values, specifically a list of ones. So you are trying to insert into this table a values, which is 1, and then you are trying to count how many 1 there is in the table. Okay, basically that's it. And then you print this information. Okay, considering what I told you a moment so far, that unfortunately seems to not be true, what do you expect to see here? Don't be shy. What do you expect to see here? Do you understand the meaning of the two queries? Any doubt about them? Okay, you see the query is executed 100 times, yeah? Okay, you see? Let's assume, I did not show you the database to save some time. Let's assume that the last value was 2010. You should have something like, I'm insert a value, so I have 2011. I collect the value, and I have 2011 again, print on screen. Then I have 2012, 2013, 2014. But indeed, we do not have this kind of behavior, you see? We have 1, 2, 3, 2011, then 2012, 2013, 3, 2017, then 2018 is skipped, and stuff like that. okay? Until the moment in which we reach 310, which is 100 values higher than the starting value. Okay, so we did not corrupt the database, okay? Because if we open the database, we would see that we have 3010 ones. But you see, the execution is a bit strange, right? Because you are iterating here, but when you, maybe there is also something graphical on the slides that could help you in understanding the points. We have a behavior like this. You see, the db.run is executed, then the db.all is executed, and while the db.all is still running, the db.run is executed again. There is a bit of overlapping. So we have this very strange situation. Okay, is it clear the reason why? Yes, okay, thank you. I'm not sure if you are still sleeping or if I'm really bad in explaining the concepts. I hope it's the first one. So to solve this kind of issue, where is the problem? That to execute the db.all, we should be 100% sure that the db.run is completed. So we should, for instance, move this kind of code inside the callback of the db.run. But again, then we don't know how, when the db.run is executed again. So we should write something strange, you know, because in the first query we need the content of the second one, and in the second one we need the code of the first one. So we have this very what the fuck situation, as it was wrote in the slide, which is called callback hell, like the place in which bad people goes. I mean, because it's something very difficult to manage, and probably I'm not 100% sure, but probably we would give you this possible solution, which is called querysync.js, to just show you a way to manage this kind of behavior, but it's not recommended because it's something very, very old. So there is a tricky way in which you use a switch and then you select the query according to some parameters. But this is not something suggested right now, because obviously engineers are used to problem, and when we found the problem, usually we try to find a solution. And this solution to callback hell in JavaScript is called promise, which is a concept introduced in ECMAScript version 6, which is the version that we are using as reference. This is one of the reasons why we use this version, because they introduced this construct that is very useful. And I already spoiled you the name of this very tricky situation that occurs when you want to perform multiple asynchronous actions in a row using callback. And you see here, you see basically a recursive program in which you have this question that is continuously asked, and you have the 3 dots because this program could be wrote in this way forever, basically. And you see, when you start using many callbacks, the code starts to become a bit complicated because you are nesting a lot of code, and you know this is something that you typically don't want. So what is a promise? Basically, is what you expect, is what the word means. Is a promise. You are promising to your code that in a certain point a value will arrive. So this feature, as I told you, simplify the asynchronous programming, is a possible solution to callback hell, and we will see that later today is also a fundamental block for another functionality of JavaScript. So this object represents the eventual, as it was written there, completion or failure of that asynchronous event. So the asynchronous event could be successfully executed or not. And Promise also standardize a way to handle error, which is something very useful. And we will see that is something that if you are used to object-oriented programming, is very similar to the try-catch mechanism that is used in Java, for instance. This time you find something similar between Java and JavaScript, but remember that they are two very different languages. This is just a luck, I would say. Okay. Promises can be, as it was written, created or consumed. So create a promise. A promise means saying to your program, I promise that I will give you some values. While consuming the promise means, okay, I need to use these values. So the promise starts in a pending state, basically. And in a certain way, you will have a response. That could be, as I said, fulfilled. So I maintain my promise, I give you the value, or reject. So, okay, in a certain way, I still maintain my promise because I give you some results, but it's not what you expect, it's an error. Okay? So we create the promise with a new keyword, because basically they are objects. And we, again, nothing strange, a callback through an arrow function. So we have the resolve and reject keywords, which are two different functions created by the language itself that you have to call. And so you create your promise, you execute some task here, and then when the task is successfully executed, you resolve the promise, passing some value, for instance, objects, whatever you want. Otherwise, if something wrong happened, you reject the promise and you give an error. So we failed, that's it. These functions are, okay, as is written here, okay. Okay. Again, I repeat the question for the recording. So are you asking me, we have to write resolve or reject specifically, or we can write whatever we want there, right? Is this the question? Considering that these are parameters of this arrow function, I'm quite sure that you can write whatever you want here, but again, we have to try it. They should not be keyword, because basically here you are invoking the function that is given as parameter to promise. Okay, so it is the construct of the object. So probably you can write here whatever you want. You are not forced to write resolve or reject, but they are the conventions. If you want later, we can try and see if that's it. But theoretically, you could write basically whatever you want. Okay, here we have an example of an implemented. Do I answer to your question? Sorry. Yeah? Okay. So we here we have an example of this. So, for instance, you can see a method. We have a function that is called wait promise with a duration. This function returns a promise and check the value of duration. So if duration is lower than 0, an error is thrown that basically said, okay, time travel not implemented, so you cannot wait a negative times. Otherwise, this function called a setTimeout function that basically invoke the resolve function after a certain amount of time. So basically, it's just return that's okay, nothing more. It does not return any kind of value. So this is used also to show you that you can even resolve a promise without returning anything. So for instance, if you have a very heavy operation on the database that should not give back any results, you can just say, okay, when you finish to work on the database, resolve the promise, and that's it. This is the other part of code in which you are consuming this promise. So you will see this is the syntax that we are going to use. we invoke the method waitPromise, which is the one that I showed you a moment ago, and we concatenate this .then method that manage what you should do in case the promise is fulfilled. So we expect to have a result that, as I show you in this case, is nothing. So for instance, this console.log print success undefined because we did not return anything. Otherwise, if there is an error, so for instance, if we pass a negative value, you will have error, and you will have this value here. So we create this error with time travel not yet implemented, so you will read error time travel not yet implemented there. And obviously here we did not assign any value to the waitPromise, so the set timeout is set to 0, so basically the function is executed almost immediately, not exactly immediately because, as I told you, JavaScript is not 100% multi-thread, so probably it was not able to create the thread immediately, it depends. But basically here, you will have a result almost immediately, while here you will have the result after 1 second. Catch is not mandatory, you can omit it, like you can say, okay, I don't want to manage the error, I'm only interested in the result. But obviously, if you try to call this kind of function without the dot, then in strict mode, you will have an error because you have to collect the value returned by the promise. Do you have a question? No? Okay. Okay, the then and the catch, we already discussed them. Okay, we have also the finally. This is one of the reasons why I told you that this is similar to Java, because in the try catch you can also have the final block, and obviously if you are familiar with this kind of concept, this block is executed in both cases. So after the then you will go in the finally, and after the catch you will go in the finally. Considering that all these methods, in the way in which they are built, return promises, you can concatenate them. So you can write the waitPromise dot then, and instead of exactly as it is written here, okay, you have the dot then, the method, the dot catch, and then you can also have dot finally and manage also this additional case. Here you have the graphical schema to say, okay, here is where the promise is resolved, and this is when the promise is managed. Here, to partially answer the question of your colleague, here, then and catch are obviously reserved words. Here you have specifically to write dot then and dot catch. You cannot write anything else. Okay, considering that promises should return promises, you can even concatenate them and processing more information line by line. For instance, let's suppose to have this method which is called get repository information that retrieves, for instance, I don't know, a set of values from GitHub, GitLab, or whatever application of version control you're used to do. When you have this kind of information, so you wait that the web application gives you the results, then for instance you would say, okay, now that I have the repo, give me the issue associated to this repository, and you will obtain, let's suppose that obviously this get issue return a promise. So when this get issue is resolved, you can say, okay, now that I have the issue, please say me who is the owner of this issue. So you access the issue.owner_ID and you retrieve the value. And then when you have the owner, you can say, okay, now that I have the owner, I can get the email, please send an email. Let's suppose that all these methods have a promise, you can concatenate them and write something like that. So you can chain, and obviously you can also have a global catch and a global finally that is executed obviously, the finally will be executed in the end, while the catch could be executed if one of these promise fails. Obviously, it is important that this method return results, otherwise, obviously, you can't get the result of a previous promise. But that seems quite obvious. Okay, and obviously, you avoid the so-called callback hell that we see a few minutes ago. Okay, this is just a simple example using fetch, which we will see something. It's a method that we could use to get some information from the web. But the concept is that I don't want to spend more time here. Just a note about promises. They can work also in parallel, even if, as I told you before, JavaScript is not natively multi-thread, multi-process. With this kind of callbacks, you reach something which is asynchronous, and so you can even invoke many promises and then wait for the values of all these promises. So you have two different ways. You have the promise.all that basically is wait for an array of promises. So you give this array of promises here, and when all the promises are fulfilled, you get the result, and you can, for instance, print in the result or whatever you want. Okay, as it was written in the slide, if just one promise is rejected, this method fails. So all the promise should finish in the proper way. And another stuff that is particularly tricky from a point of view is that this input array could also contain non-promises values. So you can put some promises, some integer, a string, stuff like that. And these elements are managed as fulfilled promised. So if you need to have some operation on the content of this method, and you want extra values that are not the promise, you can just put in the promise array and access them. While on the other side, we have this promise.race that works basically in, I would say, in the opposite way. But the concept is that while here I need to, I create several promises and I need to collect the data from all of them. Here I create different promises and I want just the value of one of them. So when the first promise is fulfilled, or obviously reject, this method is triggered. And you probably notice that after this method, you have the then and the .catch, and that's why promise.all return a promise, basically with the content. So it's a bit recursive, but that's how it works. Okay, before moving to the async-await construct, that is the concept that I told you before, that use promises to create an extra layer, I would say, of synchronicity. Maybe we can have 20 minutes of break now, because I see that you start sleeping. So, or as you wish, we can go on and then have a break. Do you have preference? Break. Okay, let's stop here. See you at 9:50.